Continuing our discussion of composite functions, here's two more functions, h of x and g of x. I haven't told you what to do here. H of x is square root of 9x minus x squared, and g of x is 2 over x squared minus 1, all of that cubed. And so the task here is to write as composite functions in a natural way. So what's going on here? H of x. If I were to ask you, how to compute h of x, for some particular value of x here, what I think that you would probably do is that you would compute 9x minus x squared, get some answer, and then take the square root of that. And so that suggests that first, that we're going to have two things to do here. One is to compute 9x minus x squared. And then the second thing to do is to take the square root. And so if we do these two things, we should be able to get h of x. Now we just have to be careful with what's the order. What's the order here? So first we do the f of x, 9x minus x squared, and then we do the square root here. So first we actually put that on the right, not on the left. So h of x is going to be g composed with f of x. It's going to be g of f of x. Because when we compute this, first we do 9x minus x squared, that's f of x. We take our answer from 9x minus x squared and take the square root of that. Let's see here. But by the way, I should point out the other thing I want to do is also just ask about domains here. What's the domain of h of x here? So 9x minus x squared, that can be anything. We can plug in any numbers we want to into 9x minus x squared, but then the resulting thing, when we take the square root of x, we want the thing that we're taking the square root of to be non-negative. We want 9x minus x squared to be greater than or equal to 0. So if we, let me say, this is our domain calculation. So if we do 9x minus x squared is greater than or equal to 0, if we solve this, 9x is greater than or equal to x squared. And so solving this, I'm just going to say you get all x such that x is between 0 and 9. If x is bigger than 9, if x is bigger than 9, you fail this, but if x is negative, you also fail this. Okay, so that was the domain of, we wrote h of x in this composite function way. For this j of x here, how would you do 2 over x squared minus 1 cubed? Well, another, I bet that if you do this, I'm going to use a of x and b of x here as our functions. I bet you would probably do x squared minus 1 first. And then after you take the x squared minus 1, you cube it and do 2 over that. So you do x squared minus 1, you cube that answer, and then do 2 over that. And so we can say here that j of x is equal to, once again, we have to be careful with the order. This is b of a of x. We do this one first, so it goes on the inside. This one second, it goes on the outside. This is b composed with a of x. But let me also note here, this isn't the only way. This isn't the only way that you could write j of x. So for example, let me use two more letters here, C of x and D of x, that we could have, instead of doing this, maybe you would have done all of x squared minus 1 and cube that first. You could have done x squared minus 1 cubed, do all of that first, and then after that, you do 2 over x. And so in this case, you would also get that j of x is equal to d composed with c of x. So in general, these kind of, if I ask you, write this as a composite function, it's not going to be unique. There might be more than one way to do that. To finish off, this thing here, let me just kind of squeeze in here for the domain. So for the domain here, let me use a of x and b of x. So x squared minus 1, that's fine. The domain of x squared minus 1 is all real numbers here. We just don't want to be dividing by 0. So we want x squared minus 1 to not equal 0, which means we want x squared to not equal 1, which means x can't be plus or minus 1. So all x such that x is not equal to plus or minus 1. Okay, so that example, I hopefully was instructive, going from this kind of, writing it out in this way and saying, okay, can you write as a composite of two functions here? Okay, one last example here in our little composite functions tour. Given f of x is the cube root of x, g of x is x squared minus x minus 6. I'm asking you to find the following composite functions. I need to write those out here. G composed with f of x. Okay, so this is going to be everywhere we see an x here in g of x, we replace it with the cube root of x. So it'd be the cube root of x squared minus the cube root of x minus 6. Of course, the cube root of x is x to the 1/3. Cube root of x, oops, I forgot the cube root right there. Cube root of x squared, x to the 2/3 minus x to the 1/3 minus 6. And then for g composed with g, here's the other thing I want to ask you about. This is simply doing the composition of two polynomials. So everywhere, so we're going to have g of x is x squared minus x minus 6. And then everywhere we have an x, we're going to replace that x with x squared minus x minus 6. X squared minus x minus 6. So, where those red things, those are formulas for g of x. If you want to, so this is a perfectly fine final answer. If you want to evaluate, simplify things, you get x to the 4th minus 2x cubed minus 12x squared plus 13x plus 36. Okay, so I think that kind of wraps up our composite function tour. And I said this will be important a lot in future sections.